Good morning, Miss Neville Science students. Here's our recorded lesson for the pulley, our last main simple machine. Now we want to remember that simple machines, their design, their purpose for existing is to make our work easier. Yes, it helps us to either reduce the amount of effort force we have to use or reduce the feeling, the amount of the feeling of the load that we have to pull. And so what we're going to be talking about today is the pulley. Please draw this picture in your notes. Feel free to pause this so that you can get this picture completely. It's important for us to know some specific parts of the pulley. Okay, there's a specific grooved wheel, a wheel that has a groove in the middle of it. Feel free to Google it. A wheel that has a groove in the middle of it there to hold that string or the rope that helps our pulley to work. It's important for us to know that the wheel of a pulley has to be grooved in order to be able to secure our rope so it doesn't slip off, which could cause injury and isn't safe. Another part we need to understand is the effort force is where that green arrow is. That effort force is where we put in the effort to really pull that load up. And we want to remember that with the pulley, our resistance force, that opposite invisible force that's acting against our effort force, will always be located where our load is. It's important for us to know that the simple machine is used to lift a load from a lower level, lower elevation, to a higher elevation. So if I'm taking my couch or a heavy piece of furniture into an apartment building that only has stairs and no elevators, a pulley system may be a good idea for me to use. We also want to make sure that we understand that the pulley is so effective because it changes the direction of the effort force that is required. So instead of me just pulling up and down with a pulley, I'm going to pull to the side. That changes the direction of the effort force that I need to use in order to lift my load. So just like we talked about that grooved wheel, we see a grooved wheel here on the right side of our screen versus a non-grooved wheel. When you look at those, which one would you like to hook up to a pulley so that a rope can be secured there? Wouldn't you like to use that grooved wheel there on the right? Absolutely. The question we want to make sure we're able to answer here with an emphatic grooved wheel is which wheel would hold the rope, secure that rope best? And it's definitely the grooved wheel. So when we're looking at types of pulleys, we'll want to draw these pictures today in our notes and label them correctly. We have something called a movable pulley. A movable pulley is where I can move the grooved wheel, disconnect it from this, move that grooved wheel and put it somewhere else to help hold my rope. Or we have something called a fixed pulley, like what we would see with a flagpole. A fixed pulley, this grooved wheel does not move. It's hooked there, it never moves. Or the movable pulley, I'm able to move it different places. Please draw both of these pictures and label them in your notes now. So when we're looking at that fixed pulley or even the movable pulley, we're still going to be able to find our effort force and our resistance force. It may be a good idea for you to label the effort force and resistance force on these two pictures that you've drawn here already in your notes. And Miss Neville wants to make sure you understand here that our load will always be the object that's being carried. Okay, we want to make sure we understand the resistance force will always be where that load is. My effort force, or EF, is where I'm going to pull down. But then we can see it on a different type of pulley where the direction is being changed. Instead of pulling down, I'm pulling up. My resistance force will always be where my load is. And my effort force in this with this pulley, I'm pulling up. Okay, and so it changes the direction of my effort force. So we're going to do an experiment in class today that's going to be recorded. So if you miss class, please feel free to watch that experiment. Okay, and the testable question we're working to answer today is, how do we make a pulley more efficient? In order to prepare for this lab, you want to make sure you've drawn and written, copied in your notebook, virtual pulley lab report. You want to make sure you've copied in your notebook this example of a lab report. Here, Miss Neville isn't giving you the testable question like we usually do. Instead, I'm telling you what a testable question should look like. Your assignment today, after we finish our pulley lab, is for you to identify the correct testable question, identify the correct hypothesis, to be able to put that data, fill that data into that chart, which if you're following along with us in class, when you do the activity, it should just be a simple drag and drop, copying the answers from your notes. And you want to make sure you choose the best conclusion. So you writing this sample lab report down helps you to choose the best testable question, hypothesis, and conclusion. It will also help you to complete the chart using the correct data. All right, guys, have a really great day. I can't wait to see you in class. Bye.